All right, so we're going to take a look at rationalizing a denominator, but more right now a review of multiplying binomials and reintroducing the idea of a difference of squares. So let's take a look at this first problem. And I know this first problem is a difference of squares because I have the same term first in the binomial, in both binomials, same term at the end of the binomial, and the only difference is I am having the opposite sign inside of each binomial. Oh, there are a lot of F-16s flying around here right now. So let's go ahead and multiply this together. Now I know there's a rule that makes it go a little bit quicker, but I'm more interested in the y right now. C times c is c squared. C times negative d is negative cd. D times c is positive cd. D times negative d is negative d squared. When I combine the similar terms, I get c squared. And notice how negative cd plus cd is 0. It cancels out. So I'm left with c squared minus d squared. And this canceling out of the linear term, the middle term, is really important when it comes to rationalizing denominators. And notice how the same thing will happen here. I'll get, 2r times 2r is 4r squared. 2r times 5 is 10r. Negative 5 times 2r is negative 10r. Negative 5 times positive 5 is positive 25. And notice how it cancels out again. Now this is a fundamentally different situation from this one because we are squaring a binomial. This is a square binomial, not a difference of squares. A square binomial is the binomial times itself. So when you multiply it out, you get p, it's not a p, squared plus 4p plus 16. 4p plus 4p is 8p plus my 16 plus my p squared. So notice how in a square binomial situation, the linear term does not cancel out. This problem is included here to show the difference between a difference of squares and a square binomial. So let's look at how this applies to irrational numbers. We have a difference of squares here again. And we know that the linear term is going to disappear, but I'm going to multiply it out anyways. Square root of 7 times square root of 7 is square root of 49. Square root of 49 is 7. Square root of 7 times 5 is 5 times square root of 7. Negative 5 times 7 is minus 5 root 7. Negative 5 times positive 5 is positive 25. Notice how we have opposites which cancel, so we get 7 plus 25, and 7 plus 25 is in fact 32. Well, how is that helpful for rationalizing a denominator? Well, I'm going to introduce a vocabulary word before I do that. If I have my 7 minus 5, the conjugate, I'm probably misspelling it. The conjugate is what would we have to multiply this by to get rid of that square root. And it would simply be this piece up here. So if I want to get rid of this square root here, I would have to multiply it by the conjugate. In other words, the missing piece of a difference of squares. So the missing piece will have the opposite sign plus. Same thing in the first term and same thing in the second. Oh, not 6. And when I multiply the numerator or the denominator by, I have to multiply the numerator by as well. All right, so 6 times 3 is 18. 6 times 2 is 12. And I still have my root 3. I realize my 12 might be a little hard to see. Okay. All right, but in the denominator, I know this linear term is going to cancel out. So we have 3 times 3, which is 9, and 2 root 3 times 2 root 3. And that's a negative, right? So we are going to have a negative. And so what is 2 root 3 times 2 root 3? Well, multiplication, I can change the order of anything that I wish, and it will get the same answer. So I'm going to reorder this because I have 2 times the square root of 3 times 2 times the square root of 3. I'm going to put the 2 times the 2 together and the root 3 times the root 3 together. What is 2 times 2? 4. Root 3 times root 3 is square root of 9, square root of 9 is 3. 4 times 3 is 12. So if I multiply the square root of 3 times the, 2 times square root of 3 times 2 times square root of 3, I get 12. And since we're starting, we know it's going to be negative, we're going to have negative 12. Well, at this point, I can combine the similar terms. Well, what is 9 minus 12? Well, 9 minus 12 is just negative 3. And so we have 18 plus 12 times the square root of 3. Now, you may notice that 18 and 12 both share a factor of 3. So I do need to reduce this fraction. So this problem is a little bit more complicated in that respect. So how many times does negative 3 go into 18? 18 divided by negative 3 is going to be negative 6. How many times does negative 3 go into positive 12? Well, it goes in negative 4 times. And we still have the square root of 3. So the trick, once you get to this point, is to realize you're dividing both the 18 and the 12 by this denominator. And you have to go ahead and multiply both pieces. So this is my final answer. Let's see what we've got. Oh my goodness, that looks like a long one. All right. Show that these are roots of that equation. I think we have another video for that, so I think we're done.